Our last topic in section 5.1 has to deal with these complicated looking problems where we're doing more than just one type of property. So the questions that we've been talking about were only just the product rule or just the quotient rule. This is the first question that we have a combination of the two rules, that we have product and quotient in the problem. So notice we have like terms on top, and we have like top to bottom. So what happens when you have like bases on top, like bases on the bottom, and like bases as a quotient rule and a product rule? Well, the first thing that we want to do is we want to make sure you understand what are our bases. So let me start underlining our bases. So we know that this 10 is an exponent. It's not a quotient. So it applies to the first thing it touches, which is the D. This 6 applies to the first thing that it touches, the D as well. This 5, first thing it touches, this D. And the first thing this 2 applies is to this D. So we have like bases on top, like bases on bottom, and then like bases going in this direction as well. So I wrote out some steps. It's called combination of rules. We're going to be adding to this list. Okay, so just know that there are more than these rules for combination. But for 5.1, since we only learned 2 rules, the first thing is make sure that every variable has an exponent. Okay, so if you don't see an exponent, write in the understood one. Every guy that we had up here had an exponent, but we saw if you just had D and no number for an exponent, slip in a 1. The second step that you would do is you're going to do the product rule. Okay, so you do product rule, not quotient rule first. Do the product rule. The product rule says that you're going to separate and treat the numerator, the top of the fraction, separate from the denominator. So what you just do is cover up the denominator and see if you have any like terms on top. And then vice versa. Cover up the top and see if you have any like terms at the denominator. If you have like terms going across, okay, then what we're going to do is just do the product rule. Keep that same like base and just add the exponents. Once you do that, then you're going to see, do we have any quotient rule? Do we have a like base on top? Compare it to the like base on the bottom. If that's the case, then we're going to keep that same like base, and then you're going to subtract top exponent minus bottom exponent. In the future, we're going to be asking the 2 questions. And if you had any coefficients, then you have to simplify and reduce. Okay. So notice each of our variables have a base, have an exponent. If one of these didn't, that's where I put in a 1 so that I can underline it as a base. Step 2 says, okay, let us use the product rule. How to use the product rule? It tells you you're going to ignore the denominator at first. Just focus on the numerator. This is technically the product rule. Why? Because this and this together is secretly multiplication. Okay? When it's on the same line and you don't see any operation, it's understood as multiplication. So I have 10 D's here and another 6 D's here. Add them. 10 and 6 is 16. Keep the same base. D, D, keep it as D. And just add 10 plus 6 is 16. Now, cover up the top and focus on the bottom. D, D, like bases, and it's understood as multiplication. Why? Because if you don't see an operation, it's understood as multiplication. And because they're on the same line, both denominators, it's multiplication. So, D, D, stays D, add the exponents. 5 plus 2 is 7. Okay? So notice I did the product rule first. Collect my like terms on top, Then I collect my like terms at the bottom. Step 3. Now that this is more condensed, we can do the quotient rule. We can take, there's 1 on top and 1d at the bottom. D, we can keep it as d. And do top exponent minus bottom exponent. 16 minus 7, you know that that's going to be d to the 9th. So it's a little crazy here because you don't know, should I do 10 over 5 and 6 over 2, or should I go this way? You want to get used to looking at your product rule first. The reason why is because I know some people might say, 10 divided by 5, that's 2. 6 divided by 2 is 3. And remember, quotient rule, even though when you see a fraction par, you don't divide these two numbers, okay? When it's the quotient rule, you subtract. So I like to say that to the end. Combine, and then you can see, wait, 16 and 7, they don't divide out. And then you realize, wait, I don't supposed to divide. Exponent's supposed to subtract top minus bottom exponent. Because the question, if you have it here, do I subtract this with this? Do I subtract this with this? Should I do this with this or this with that? It's easier to combine the tops, combine the bottoms, and then do the quotient rule. Let me do one more for practice, and then we can give you your sample question. So let me do one that probably has no exponent for one of them. And we can do one with a coefficient. So let's do this guy. Again, I do see that we have more than one property. How do I know I have more than one property? It's because I have A's on top, A's on the bottom, so you know that's one property, the quotient rule. But I have A's next to each other. So that's another property, the product. So I know this is a combination. So the first thing I want to do is make sure that every variable has an exponent written. Yep, no. Remember, if you see a corner that does not have an exponent, slip in a 1. Now, step 2. Treat the top separate from the bottom. So if you have to, hover up. Focus on the top. Do you have any like bases? 5, A. Remember, this A is applying to this A. This 1 is applying to this A. So A, yes, we have like bases. 8 plus 1 is 9. This 5, just bring it to the side because there's nothing to combine it with. So I was able to combine these 8 A's plus this 1A to get 9. Now let's focus on the bottom. Is there any like bases? Well, this 4 only applies to the A. 15 and A, now they're not the same base, so just bring it down. Next. Now that we only have one A on top and one A at the bottom, we can do our quotient rule. So step 3. You can either ask yourself the two questions, where do you have more A? Top or bottom? On top. By how many more? If there's 9 here and 4 here, if we did the canceling, there'd be an extra 5 on top. Okay. Or if you rather do top exponent minus bottom exponent, you would have A, 9 minus 4. We'll have A to the 5th. Now how do we take care of this fraction? Well, in this method, you would have 5 over 15, and you would see how you can reduce this. Or if you're doing this method, you would have broken 5. How do I break down 5? It's the prime number. How do I break down 15? Ooh, 3 times 5. And you can see a 5 on top and a 5 on the bottom cancel out. So if you did it this method, you have a to the 5th over 3. If you were doing this method, you would have 5 over 15. You would still factor out the top, factor out the bottom. See that a 5 and a 5 cancel out, but if you have nothing left on top, you have to say that there's an understood 1. So 1/3 and then a to the 5th on the side. Both of these are equivalent to each other, okay? So it's whatever you feel more comfortable for right now, but I'm going to tell you, I'm going to gravitate more to this way because there's going to be occasionally where we might have more a's at the bottom.